Okay, let's jump into our next presenter. She is coming from San Francisco, US. She is Dr. Sohini Roychowdhury. And the presentation will be unveiling the 3 steps to create sustainable and trustworthy generative AI products for finance-based use cases. Sohini was a university assistant professor in Washington. She's also now head of AI and machine learning and generative AI products at Accenture. She actually has a nice YouTube channel called AI with Sohini. So if you want to follow her on YouTube, you can do so. And the fun fact is she has a band of traditional Indian songs, and she can also play on the drums. It's really interesting. So without further ado, I would like to welcome on our stage our first speaker of the afternoon, Sohini Roychowdhury.
Thank you so much. Welcome, welcome. Well, I'm audible. Okay, so we are going to be talking about generative AI. Generative AI is when we use chatbots like ChatGPT in order to build solutions. Now, raise of hands, how many people have actually tried ChatGPT? Anything? Okay, all right. So I'm talking to a room full of audience who's well equipped and aware of the topic, so let's get into it. So let's try to understand what generative AI really is. Generative AI, for the first time, it has reduced the bar to entry into the field of artificial intelligence because of its unique capability for translation, for automation, and for intelligent decision-making in our day-to-day lives. What does that really mean? That means I have a LinkedIn profile, and I want to embellish it with all of my experiences from these wonderful conferences. What do? I take the text that I already have in my LinkedIn, I combine it along with the definitions or the text that I have for my slides today, and voila, with a few lines, I now have an embellished LinkedIn profile. So ChatGPT has really revolutionized some of the very key use cases that we see in our day-to-day lives. So let's take a look at a few applications so far. Building resumes with ChatGPT. There are so many videos on YouTube right now. Just Google it. Videos about embellishing your applications or embellishing your resumes with ChatGPT. You will get the steps in order to do that. And the next, which is one of the recent ones, is the product by Runway. It's a company in New York. What they've really launched is just by a few words, it can generate up to a 3-second complex video. So now video generation from text is really feasible. Continuing on the same path of image generation, Meta's latest model, which is called EMU. EMU is capable of generating very complex and distilled images just from prompts. So gone are the days where the only foreground is visible and the background is poor quality. You actually get high-end definition background as well as foreground from just a few lines of text. And finally, something that I'm using right now, it's Duolingo. How many of you have used Duolingo to learn languages? Awesome. I am using Mi Hablos Poco Español, and I'm doing that using Duolingo because now it has a feature which is called Explain My Answer. So for some reason, if your answer goes wrong, Duolingo actually has the capability of telling you the context. It'll give you examples so that you understand where you really went off. Now that's the power of personalization that generative AI brings to the table. Now let's take a look at what is generative AI, how did it really come about? Now Gen AI has the capability of distilling not just text, but it can work on imagery, audio, as well as data tables. And it was popularized by this recent release of ChatGPT that happened in 2022, November. And it came about after a huge slew of GPT models. Now, GPT stands for Generative Pre-trained Transformer Models. Generative Pre-trained Transformer Models have been worked on for quite some time now. But the basic difference between the previous models and the current model is the safety layer. What that really means is the precursor to GPT-3 was called Instruct GPT. You could actually go to Instruct GPT and ask, how do I blow up my neighbor? And it'll tell you step by step on how to blow up your neighbor. So in this case, if you have malicious intent, it would still answer your question. Now that was not safe, right? So that's the reason why we came up with this whole slew of the latest LLMs or the large language models that have a safety component so that if you have malicious intent, it filters it out and it does not give you a response. The second most important capability of these generative AI, large language models, is called RLHF, reinforcement learning with human feedback. That means a foundational model cannot just be static in time and say, okay, here, I've built GPT-3, that's the best version, I'm not going to change that anymore. That doesn't happen. It has to constantly evolve with human feedback. And that is the only way of making sure artificial intelligence keeps progressing over time. Now let's understand what are the different kinds of language models that have come up so far. The first one was called encoder only, in which if you enter human text, it translates to machine translatable form, right? So input is human text, and the output is something that a machine understands. Where is it useful? These are typically models such as BERT, Roberta, in which case, if you have missing text, or while typing, maybe we mistyped a word, the system is automatically able to autocorrect. So whenever you are using autocorrect, you're actually using encoder-only models. Then comes the encoder-decoder. This gives you more control over the large language model so that you can really have a smaller set of fine-tuning and still get your responses. Some examples of this, GLM, T5. Again, everything that you will find on Hugging Face typically belongs to this genre and category. Are these models obsolete? Absolutely not. They are extremely useful even today, specifically when you're trying to do summarization and paraphrasing of any kind of content. And finally comes this decoder-only model, where everything is frozen in time. So these are called foundational models. And typically the examples are everything that you see, Llama, Llama 2, you have GPT-3, GPT 3.5, ChatGPT 4. Each and every one of them has this encoder as well as decoder pre-built. So that when you go and enter a question, you are getting responses at inference time. So that's the reason why it's very fast and it's very accurate, because it knows exactly what to do. So given that these three are the genres of the different language models, let's try to understand what are the ways of working with generative AI. Now, large language models typically have been trained, just as the word suggests, large data. What does that really mean? Just to give you an estimate, the GPT-3 model, it has a 176 billion parameters, and it has been trained on 45 terabytes of data. Imagine 45 terabytes. That's the amount of textual data that has been used, that has gone into training something like GPT-3. Now, what are the ways in which you can start working with these models? The first one is called grounding, in which every time you enter a text or enter a question, it actually ends up generating a custom prompt. And this is the prompt that hits the large language model and generates your response for you. Then there are mechanisms which is called few shot or a single shot. Again, in these few shot cases, you are not modifying the weights and biases of the foundational model at all. The only thing you're doing is you're giving it the prompt an example. So if this was my question, this would be an example answer. And this gives the LLM a means in order to format the response. Do you want it as bulleted? Do you want it as continuous text? Do you have images that need to be embedded? What is the format? So this gives the large language model an option how to format your data. And finally comes the most important and the most difficult way of working with large language models, which is called fine-tuning. Now understand, supervised learning, whenever we were generating supervised learning from natural language processing models, it required a good amount of training data. Now what has large language models done? It has thrown that data out of the ballpark. That means now you need tens of thousands of examples to really make an impact. But can it be done? The answer is yes. So if you have models, let's say 65 gigabytes, that's the size, and it's across multiple hardware components that you have, there are mechanisms such as low-rank adaptations or quantized low-rank adaptations. That's called LoRa and QLoRa. What they do is they take a 65 gigabyte model and convert it to 3 gigabytes. So that now you can really fine-tune it just on one GPU. So that's feasible, but what do you need for that? A lot of training data. So whenever somebody tells you, let's fine-tune a foundational model, you say, okay, back up. How much data do you really have? And do I really need it? The answer is, most of the times, the answer is no. You typically need to fine-tune a foundational model whenever the jargon is significantly different. So if you're talking to a medical professional, or if you're trying to create a foundational model for the legal jargon, there the words are very different from discrete English words. In those cases, you really need to do fine-tuning. So based on your application, that's where the decision of how to work with an LLM should surmise from. Now let's get to the two major use cases of generative AI. First off, and this is the one that we are most aware of, is called personalized conversational agent. So this is the framework which is called LangChain. What LangChain enables you to do is use an OpenAI's resource and unleash it on your Google Drive. So let's say you have a drive full of documents and you want this conversational agent to go through each and every one of them and give you an answer. Now you can actually do that. So you use your OpenAI's key and you connect it with your Google Drive, and then you can keep answering questions like, what are some of the ways in which I can start to code? What are best practices? If you had written a document on that, now you can literally start querying it. And then comes the next one, which is called automation engine. Now, automation engine, this is where generative AI thrives and flourishes. So if you go back to this paper, which is called the Turing trap, it's by this professor in Stanford. He talks about artificial intelligence being in its superior glory whenever it's in the augmentative state of human nature. That means AI thrives when it does stuff that humans don't like to do, which is automation. So that's the reason why automation engine is such a thrilling experience, which is made possible by generative AI. But what is the criteria for it? If you have a group of questions that you want to keep asking to an ongoing list of input. So in this case, as I show you, I have a list of archive files, and I want to get a summary and some interesting facts from it. So I unleash this system onto these archive documents, and voila, I have the summary and the interesting facts extracted for each and every one of them. So this is actually a use case we had on one of our clients, and where they had this huge database of ServiceNow tickets, and they didn't know how to prioritize it. So we were able to generate this automation engine in a hackathon which lasted 3 days, just 3 days, and we were able to generate this solution which takes through all of their database of documents, and it generates summary as well as it prioritizes which one should be looked at first, which one next, and what department it needs to be routed to. So now you see the power of AI being unleashed in the augmentative space of the human nature. Now let's try to understand what is a typical journey for a product roadmap. Now, generative AI faces two major challenges. One is adoption, because there's a skeptical nature in us as well. Do I trust it? Do I not? What do I do with it? So the first step, of course, is to have the MVP, right? So where you understand with your business providers what exactly is the use case. You have conversations about building this MVP and the whole experimentation phase that it entails. And there are 3 major steps in it. So first off, we get into the prototype stage. During the prototype stage, we come up with a dual velocity approach. A dual velocity approach, that means a lab is split right in the middle. There is a production team, and then there is an R&D team. Now, the R&D team is constantly coming up with fine-tuned mechanisms in order to interact with the LLM. However, the production team is saying, okay, which responses are stable, and only getting them out to the decision makers. So that gets to the prototype phase. And then we slowly keep enhancing the intent. So let's say as a first phase, we only released answers to what questions. So if our decision makers want to understand what are the markets where my business is doing well, what are the market units where my business is not doing so well. So all the what questions, we enabled them first. And then we got to the how, the why, and what else can I do after that. But the final and most important component to this is evolution. No large language model can be taken as a snapshot, and we just imagine it's going to keep getting better and better over time. It doesn't happen. So the evolution phase is super critical. And that's where using these low-rank adaptations and continually having conversations with your business providers in order to get a better gauge as to what the product really wants. Now, I wanted to really talk about the 3 phases in the MVP stage that we had to consider. The first of what was it called? Prompt engineering. Now, generative AI has brought about this new area, which is prompt engineering. You'll see a lot of ads in LinkedIn right now. Prompt engineers wanted. What really that means is you want the people to be able to write these custom prompts that can be fed to the LLM to get a response, right? Then there is the infrastructure aspect of it. And finally, the UI UX. The user interface with chatbots has been significantly different from anything that has happened before, because now you need the thumbs up and thumbs down, as well as there is this option to regenerate a response. If the user doesn't really like a response, there is the capability of regenerating it. Now let's get to each and every one of these stages, one after the other. So this is a typical LLM use case, as you may. So the user asks a question. Based off of the question, a customized prompt gets generated. And this prompt gets generated using some of the data that you've already pre-stored. And that's the prompt that hits your large language model or your foundational model. A response gets generated. You get thumbs up, thumbs down, regenerate, whatever it is. And based off of that, the custom generation can keep improving over time. Now, some of the customization components that we have had to build for our finance chatbot, first of all, the question or intent classification. Understanding that every question is not answered the same way. If I ask you a what question versus a why question versus a how question versus a when question or a which question, every single one of them have very different instructions that need to be followed in a particular order to answer them. So the first step we did was intent classification so that the right steps could be gauged. The second was data chunking. So let's say that you want the chatbot to be answering your own answers from your own personal documents. There is a way in which the data needs to be stored, and that is called data chunking, so that whenever most relevant data is sought after, that gets generated into the custom prompt. So the custom prompt generation was the third component that we had to fine-tune for. And finally, this was the most key component that we had to design for, which is called the quality storing. So how do you know if the response that comes out of an LLM is good or bad? Sometimes you know that it hallucinates. It gives you all garbage answers, and there's no way for you to really know without actually taking a look at it. So that's why we generated this quality scoring mechanism that we are patenting in order to really figure out the response that came out, how accurate was it really? And I'll get into the nitty-gritty of it in a bit. Now let's try to understand the prompt engineering. So any of you, if you are interested in applying for a prompt engineering role, these are the steps that you need to know. Step number 1. We need to get to what is the header or what's the persona. So typically, whenever we are generating these prompt engineering responses, we want to say that the persona is that of a helpful virtual assistant. However, if you are cheeky and if the use case demands, you can also say, I want a comic persona, or I want somebody to give me smart answers, right? So that's the persona that you define. The second one is called the preamble. So let's say that your business has a lot of custom definitions that you need to use, like SAP. SAP is a company, but it's not really the plant SAP, right? So in these cases, they have to go into this section, which is called the preamble. Then comes the context. What is the data which is the most relevant pertaining to this particular question that I asked? And finally, the instructions. What are the steps that I should follow? Step number 1, step number 2, step number 3. And finally, the example that I talked about. So the one shot or a few shot, where you take the format of the question that the user is looking for in order to generate the answers. Let's take a quick look at what this actually looks like at the back end. So in this case, I am trying to figure out where should I invest my retirement savings, right? So I'm trying to generate a chatbot, and by asking it, what percentage of financial stocks have a steady growth in the New York Stock Exchange this week, right? It's a pretty complex question. Let's say that I have all of the data. I have a list of all of the particular market stocks and how they are doing over a period of time. But is that it? Is that it? Should I just give it to the chatbot? Will it do the job? The answer is no. You really need to feed it using a custom prompt. So what are the steps in this case? So first of all, I need to determine intent. What is the intent here? The answer says what. So corresponding to the what, there's a template, there's a list of instructions that it's supposed to follow. And then we do a deep search for the keywords. What are the keywords that I'm looking for? So it's finance, New York Stock Exchange, so all of the keywords that need to be extracted from this question. And then we get to the functions that need to be defined. So in the back end, along with the data, we also need a list of questions and a list of functions that have to be readily available. So let's say in this question, there is a way to look up all the finance stocks Then there is also a way to filter by geolocations. There is also a mechanism to finding what are the stable stocks. So what's the definition of stability? And then there is another function that counts the total number of stocks and then finds the number of stable stocks as well. So all these functions are there in the backend, right? And then I just come up with a way of structuring everything together. And finally, I give the following steps. So these are the steps in order that the generative AI actually functions. So step number 1, it identifies all the stocks corresponding to finance. Then it also filters by the geolocation. Next, it gets to the stable stock finder. Next, it counts for it, and then it finds the total. And finally, the final response is supposed to be a ratio, right? So it also determines the format in which the user wants the response. Do I want a statement? Do I just want the number? Do I want this number along with the figure along with it? So it finds each and every one of these details, and based off of it, the response finally gets generated. So that would be the flow in which you'll have to design your own system whenever you want a complex decision-making response from an LLM. So now, the prototype is built, nice and ready. What are the next decisions? Now becomes the key decision moment. Which large language do you use? There are so many in the market. Which one should you go about using it? So this is the 4-quadrant mechanism in order to select which large language models work best for you. On the left-hand side, we are going for, I want the most control over my large language model. So let's say that I want to make sure that the large language model is updated based off of when I want it. I want to make sure that the security settings and everything is customizable. And I have an extremely technical team who is capable of constantly modifying it. So in this case, the Hugging Face models would actually do a pretty good job if that's your intent. Now let's go to the other end of the spectrum, where you already have a partner cloud provider. Let's say all your data is in Azure. What do? Well, just go to the cloud provider and tell me which LLM do you have. If you are a Microsoft user, you may just go with GPT-3 or 3.5. If you're an AWS user, you might just go ahead with Anthropic, right? So if you have a specific want to keep with your cloud provider, just go to them and ask them for their LLM. Then comes the intermediate stage, where you want to access the API as just a REST API call. So you don't really want to say, oh, no, I want to keep using Anthropic all the time. I want to be able to pick and choose whichever I want to use. So in this case, you can use Llama, you can use Bison, you can use GPT-3, 3.5. You will be able to make them as REST API calls, but to you, the foundation models will be a black box. You have no control over them at all, and you don't really care about it as well. And finally comes the situation where there are extremely secret documents and there are very extremely sensitive documents that need to be mined. In which case, if you want an on-prem service, there are companies such as Sambanova that can actually install the foundational models for you at your premises so that you have full control over modifying them, fine-tuning them based off of the usage as you need. So now you have to make your decision which large language model to use. Now let's get to the challenges with any of the large language models. Generative AI, for the first time, it is now introducing issues corresponding to trustworthiness, responsible AI, as well as accuracy. So the same question, if you ask ChatGPT multiple times, if it's a tough question, it might throw a few curveballs, here and there. So what do you do in this case? There is this Stanford Helm model that has helped to baseline the performances across large language models. So we had done some of our experimentations as well, in which case we saw if you're using models like Llama or Llama 2, they typically have a token limitation. So if you pass smaller prompts in smaller context, it does a pretty good job. However, GPT-3 versus 3.5, distinct dissimilarity. 3.5 is like the talkative student that you have in class. You ask one question, they'll give you one paragraph. GPT-3, on the other hand side, you ask one question, it'll give you one in return, but sometimes it can hallucinate. And then comes Google's Bison along with Chat-Bison. Just as the word says, Chat-Bison can really help you maintain context. So if you ask which stocks are doing well this week, why? What's going to happen next week? It'll constantly figure out what the context that you are asking about the stock prices, right? So whenever there's a conversational nature to the virtual chatbot, then you have to pick your LLM based off of that use case. All right, so now we figured out how to go about picking the control over the LLM, as well as what are the challenges with the LLM. What to do now? Now comes the great question of hallucinations. Hallucinations by foundational models is when it tells you a wrong answer very confidently. You ask me what is the train time, I'll tell you right now. I'm off. I have no idea. But I just went ahead and I told you anyways. Mostly I'm right, so you'll more have a tendency of believing me. But is that always the case? The answer is no. Large language models, as the word says, has been trained on language. What does it not know how to do? Math. Because it hasn't been trained on math. So if you ask very simple questions that otherwise humans can do, large language models will have hiccups here and there. And typically the causes for it is biased training data. There is the nature of the question altogether. If it's a very vague question, it will not know what to do. There is ambiguities in the prompts that can happen, and also there is model parameters that impact these issues in these cases. Now, how do you minimize hallucinations? This might be an interview question typically. It is, at least in the Bay Area. So the first step here is called retrieval augmentation generation. That means whenever you have context, you provide an extremely relevant and accurate prompt by adding more information, as much as you can. So if it's a particular persona, you have some information about this persona, and based off of that, you're augmenting the custom prompt generation process. The next step is advanced prompting. So if you go to any prompt engineering guide, there are some basic modalities, but then you get into advanced prompt engineering. That means you start saying, what do you do if you have no response? Or if the answer is false, what do you do? So whenever you apply these additional prompt engineering mechanism, that sometimes cures the problems as well. Then control for abstract questions. So if I want to know, what should I be thinking about today? That's an abstract question. I can be thinking about anything. So the LLM is always going to get confused in these cases and not come back with a steady answer. So understanding that if it's an abstract question, you need to break it down some more. And finally, parameterization is a huge deal. So there are a lot of parameters, such as the temperature, such as the maximum token limitations, the top P. There are a lot of parameters that you have to play around with in order to see what is the best parameters for your use case altogether. Now coming to the custom quality detection module that I talked about that we built for our company. So this, think of it like an English teacher and a math teacher sitting on top of the large language model response. So every time the LLM gives you a response, the English teacher checks for the context. I asked you about Hungary. Did you give me the response about Hungary? Or did you give me the response about India? So that's the English teacher is checking for that. And then comes the math teacher. The math teacher checks, are the numbers that you are just giving me in my response, are they right? Did you just pull them out of thin air? Or were they provided to you in the prompts altogether? The third criteria is called uniqueness from prompt. So if you give the prompt with a certain language, did the LLM just regurgitate your language back to you? Or did it at least take some time to rephrase? And finally, sensitivity along numbers, and this is extremely crucial. Sometimes the LLM will come up and say, the stock prices went up by -1%. Went up by -1%? That makes no sense. In this case, the answer is the sensitivity would be 0. So we have 4 mechanisms in which we can gauge for the response quality, and as you can see, corresponding to every single version update that we do, now we can actually come up with numerical responses this is the accuracy of the responses that we see for a particular batch. And this raises the confidence of the user interactions, because whenever you have a low confidence response that comes back to the user understands, you didn't understand my question, did you? Okay, that's fine. Let me rephrase it. So that's the way of building confidence and raising adoption for large language models typically. And finally comes to the most important stage, like I mentioned, evolving with reinforcement learning and human feedback. So if this is a video, okay, this may not run today. Do we know how to run the video? Okay, let me talk through what this video does. And this is you can actually Google it. It's called Stack Llama. You go to the Stack Llama or the Llama model right now, and you ask it a very vague question. There is a llama on my lawn, what do I do? And if you give different kinds of parameters, it will give you very vague responses. One may tell you that you have to change your country, take a train, run away, and then so it has absolutely no idea what you should be doing, so it starts hallucinating. And that's what this video was about, where you change the parameters and you can see how the responses go absolutely off. So here, what's the mechanism of getting a valuable response in this case? So here, what you are supposed to do is gather a good amount of training data. So this is where fine-tuning happens. If you have a good amount of training data, then we start using proximal policy optimization, so PPO. And using PPO, now the system slowly starts to understand how to even comprehend a question like, there is a llama, what do I do? And at the end of this process, there's this blog, and it shows you that it actually gives you the right steps. It tells you there are 2 ways of getting rid of a llama: shoot it, or use a llama-specific product. At least it's not hallucinating, right? So that gives you the way of going about answering a complex question with generative AI model. If it's giving you absolutely off answers, don't fret. You just need to fine-tune it so that it gets better over time. And finally, let me talk about some of the new direction in which generative AI is actually going to. First off, OCR, optical character recognition. This has been an extremely painstaking problem in the field of AI. So if you have huge documents that are PDF, varying qualities, how do you really get the OCR out of it, right? So here is a GIF, and this is interaction with OpenAI's Chatgpt 4. You can literally upload the PDF, and it will store the OCR as a text file. Very simple instructions. It now has the capability of taking a PDF and converting it into text files. Not just that, the recent release of Chatgpt 4 can even take an image that is as abstract as this, run on a Post-it, and you can just upload it, and it will automatically understand what you really meant. So transcription and OCR has become super easy with the use of ChatGPT, and it really understands what were the diagrams that you made, and if you ask a follow-up question, it'll be now able to understand that as well. So these are some of the areas in which ChatGPT is going right now. Now, how is it really going to change the industrial data and the industrial point of, in industrial POV? Now let's get into some of the use cases as is right now. First off, a lot of industries have a lot of dashboards, so many different kind of visualization, Tableau, Power BI, all over the place. That will slowly get away with generative AI. Because now people can actually start generating their own personalized dashboard corresponding to the data that they have personalized for. So things like Power BI dashboards can slowly start to get obsolete as people start working on it at more prompt level, right? The next one would be business data definitions. Typically, whenever we have our decision makers ask for a report, we start defining the data at the time of the use case, right? So based off of the figure, I will start giving you the data definitions. However, slowly this process is going to flip, and the storage of the data definitions is going to happen at the back end, at the source, so that the custom prompt generation can be easily furnished. Then comes data management. Now, this is a very gnarly problem in industrial use cases. There are often happens that we are currently on a version 10.1. Everything has to move to version 11. So many bugs and so many checks have to happen. Automation in these cases, generative AI, is an excellent use case in these cases. For code checking, understanding if there have been any bugs or any flaws whenever you migrate from one version to the other, generative AI can do that very seamlessly. Then comes unstructured data. So if you are working in companies, you know there are a lot of meetings, and there has to be a lot of minutes of meetings. And typically, when people don't send minutes of meetings, you forget the context just because there are so many meetings. But now, generative AI can actually make that super easy to maintain as well. Because now, automatic transcription for meetings can happen. You can figure out who spoke what in what meaning. And that really helps people understand, okay, the context of follow-up email threads whenever they show up. So think about the life getting super easy just based off of this automated transcription that's coming about. And finally, data access. Now, this is again another big thing, big hurdle that we struggle with a lot of time. Getting access and having access are two very different things. I can get the permissions from the right folks, but still I don't have access yet. So an automated system can actually manage this getting access and having access so that things happen in a more timely way, timely fashion. So these are few changes that we definitely see in the whole gamut horizon of industrial data coming across using generative AI. That's all from my side. Questions, if at all? Thank you.
Yes, it's time for questions, so please post your questions via our Slido application, because until now we have no questions, so we can talk about the future of generative AI, maybe?
Sure.
A few words?
So one of the key changes that has happened in OpenAI right now, and again, you can Google about this as well, it talks about voice-to-voice recognition. So what that means is you can literally ask a question to OpenAI using your voice. You don't even have to type anymore. And it actually can respond to you as a voice. So it's not just having a question at text format and having a textual answer. Voice translations along with voice responses have also been enabled, which means that the automated content generation is really going pretty, it is progressing with leaps and bounds, and any form of data can now be worked around with. So.
Until we wait for questions, my question would be, okay, you said you're a musician. Do you see that music will be changed by AI in the future?
It is, absolutely. And there are a lot of experiments. So Google actually had started it. There is called this Google X Lab for experiments. You can, again, Google this as well. But there, you can actually build music with an AI system. So you give an initial notes, you give what kind of beats you want, and it'll automatically start generating it. And you can correct it. You can do code correction. You can change your wave, your beats, and it will actually start generating music. The fun fact is, I actually had a friend, they launched their own startup business. Mm-hmm. And now launches for startup business can be one day, because she was able to get her website up with the text written about her, with figures as well as music generated automatically. So that is the power of generative AI, because now all the planning, you'll have like thousands of options for you to choose from in just a matter of a day.
Okay, you cannot leave without questions. So low RA versus RAG, which one do you think will be more widespread ads in the future?
This is a good question. I will say that RAG is being used more right now, even with AWS Anthropic systems. Retrieval augmentation generation is, again, something that we are using more right now. So think about it, is Amazon Marketplace, right? It has information about every type of user and buyer and what kind of product they like. That kind of information, if it adds along with all of the products in the data marketplace, it'll start giving you very accurate responses as to what you really want. So you might go to Amazon Marketplace and start seeing that you may be out of tape. And that can be eerie, because you might really be out of tape. And it'll automatically figure out that that's the next product that you need. So RAG is actually being used more right now. Low-rank adaptation, quantized low-rank adaptation, there are still a lot of experimentation that is being happening. The one downside of low-rank adaptation, I will say, is unless and until you have a good slew of data to be training from, don't try to fine-tune. Because if you think your data is going to change, you might just come up with an extremely specialized version of a model that you can't after that fine-tune. So low-rank adaptations only should be done when you know that your fine-tuning data is exhaustive in nature.
Thanks for the great answer. In the quality scoring solution that you presented, are the validation steps carried out using other AI agents or by some other means?
That's a good question, and I always have this push and pull in my team. They always say, "Hey, there's a response from GPT-3. Why don't we let Llama score it, or why don't we let Palm score it?" The answer is, again, hallucinations in LLM is a fact. It's not a concept, it's a fact. It happens. So there's a chance where both of the systems are hallucinating is also a reality. So that's the reason why when we made the scoring agents, we used very controlled mechanisms. We use NLTK. So NLTK is spacey libraries where the performance is not going to go off. That's why I said that English teacher and math teacher, something very specific, just that can be done by very basic NLTK models that you have full control on, which that are not going to go off. So that's the strategy we used in order to generate our quality scoring.
Okay. When will we achieve 100% accuracy? I'm concerned to introducing LLMs to our B2B software as a service products. Why there is still hallucination going on?
Hallucination is going to continue, and I hate to break it to you, it's going to happen. The frequency with which it happens might go down, but you have to control for hallucination, and that's the reason why scoring engines are super relevant and very important right now. When will it get to 100%? Well, I don't think even doctors can give you a diagnosis with 100%, right? They always say 99% that this is going to happen, and that 1% chance that it's always going to go off. So that's the reason why multi-agent systems are becoming a reality. So llamas right now are getting used to generate or even structure your data. So let's say you have a huge data table. If you want to structure only a few rows out of it, llama can actually structure data for you. So multi-agent systems and combinations are being considered, but when will 100% accuracy happen? It may happen in one batch of data on one day, next day it might change. So my answer would be, I don't think it's going to happen in the near future or in the reality.
Okay, let's see the last question for today. Do you see the power of LLMs compromised by new legislation?
Oh. I don't think the power is compromised. I understand what you're saying and where you're coming from. ChatGPT 4 and then the ChatGPT 5 being banned after that, and there being a significant gap after that. But then there was a reason for that as well. I somehow think that in the interim, while there's a gap between ChatGPT 4 and 5, there will be a lot of specializations and personalizations that is happening. So Duolingo was the first product to actually come off on market. Every company is trying to build their own foundational model and their own version of it. Bloomberg has their own GPT. So Bloomberg GPT has question answering and prediction capabilities as well. So I don't think that it is going to get worse, but I think there's going to be a lot more experimentation and a lot more personalized aspect in this period that has been a halt brought about by the legislation.
We have 1 more minute, so the last question can be answered. What kind of revolutionary step can happen in AI in the near future?
This is the visionary question, and this is where I think that Turing trap paper is most relevant. Understanding where does AI flourish and where is it not. So in my job before Accenture, I was actually at autonomous drive. So I was doing autonomous drive for Volvo cars. Huge amount of question, answer, moral, ethical responses. Why? Because humans like to drive. If you're making an AI do something that humans like to do, what do you think is going to happen? There's going to be a lot of backlash. But now if we come to automation, crunching numbers, generating reports, we hate doing that. If an automated system can do that for us and then say, hey, these are all of the reports, this has been prioritized and scored, now go through each and every one of them and tell me which one you like. Automation is the space where LLMs can really benefit. Now, I think even with travel, like I do not understand Hungarian, but I did not think that language was a boundary anymore, just because there are so many translative apps that do language-to-language translation, and it can even give me very accurate data about travel in a new country. So I think these are areas for translation, for automation. That's where AI flourishes, and that's where it can really revolutionize by reducing the entry boundary. Like I mentioned at the beginning, there was a time for people to be data scientists, you really needed to know Python. So it's the first thing you ask at an interview. Do you know Python? Now the question is, do you know prompt engineering? Prompt engineering has no Python. You just need to understand how to structure the data, how to put the instructions in. So that is the revolutionization, right? So where you reduce the entry barrier, and you keep growing as the technology and data progresses. That's where I would leave it at.
Thank you very much for the visionary thoughts. And I would like to ask for another round of applause for Sohini.